Okay, so we are a little bit late and people are starting to get really tired. And I would like to give Natha, that is the very last speaker, some the attention that he needs to have. So let me introduce to you Natha. Thank you, Nat. And we go now to Natha. So Natha is my partner in crime to the creation of FTS. If we today have an FTS, that is because of the incredible job that Natha has done in the last couple of months. Natha has really done some stuff that most people will consider to be impossible or incredible. And I know what is happening under the cover. So let me welcome Natha and thank you. And please listen to Natha because he has a couple of things that are really important to understand in order for us all to become better developers. Go on, Natha.
Hi, thank you so much for that introduction, Gio. Uh, as you said, my name is Natha Paquette. I am the lead developer on the FTS project. Some may know me by my alias ghost108 or Naman108 on GitHub. Uh, Today, I will be discussing the FTS development strategy. Uh, so, we'll just go over the agenda, beginning with a description of COT for those of you who are not familiar. That's fine. Just a general idea of what exactly it is, use cases and implementations within not only the context of the TAK family of devices, but just generally. We will then move on to the challenges which we at the FTS team have faced, concluding with how we solved these issues. So let's get right into it. What is COT? COT is an abbreviation for cursor on target. It is a data strategy uh, which centers around the use of a common language for various tactical systems and assets, not only on the battlefield, but also in emergency response and many other use cases whereby situational awareness is of the utmost priority. It is a method of, it is a standard of communication intended to facilitate the transmission of data between a variety of systems. Uh, However, or not however, but as a result of this, it needs to be highly extensible as the amount of information ranges from anything like the current trajectory of a smart bomb or the location from your GPS tablet, right? So there's just a huge variation in the data which is being transmitted, and this is the reason for the extensibility. However, there are three central concepts which are essential in every COT. First, the what of an event, the when, and the where. Not necessarily only events, it could apply to assets or other systems. So moving on to the challenges which we at the FTS team faced. Uh, the first challenge was that COT, as I said previously, is designed to be expanded. Now, this is a huge asset, and I in no way feel this is a bad feature, as it's essential for COT to maintain a standard in the long run, because it needs to adapt to every system which is now implementing it. However, this has resulted in the merging almost of the technology and the standard or specification. Uh, what I mean by that is the specification has been adapted on a technology to technology basis, which leads to some nasty things in the long term. For example, obsolescence of many methods or standards which are included in the code or need to be supported in certain client applications. Uh, or repeated implementation of certain methods between which could be differentiated between within the system in its entirety. This is the result of lots of different teams creating these extensions and implementing them, but most of which, the biggest issue is the fact that there is no, as far as I understand, no universal specification applying to all standards which or extensions which have been created. And we believe at the FTS team that, with all due respect, we can do better. Now, I've explained what COT is. However, TAK protocol falls into three central versions. Version 0 is the version which you are, I trust you're most familiar with. Those of you who are familiar with COT, it is the version implemented in XML, and it is the version which is by necessity supported by every TAK device or device within the TAK family. Then we have version 1, which is implemented in ProtoBuff. Now, ProtoBuff, if you're not familiar, is a standard developed by Google, which is by design compressed by the by reducing duplicate data in the message, and it uses a very similar structure to JSON. And lastly, version 2. Now, we know nothing about version 2. We know that it exists, but if you know anything about version 2 that you can legally share, please do, because we are dying to know at the FTS team. There have been some references to it, but other than that, absolutely nothing. So just to return to version 1 for a moment, they faced in development of version 1 a lot of the same challenges which we did in integration of COT, being the propagation of extensions within messages or within the COT structure. Now there are two ways which this could be solved. One, re-implement all devices to send messages over this protocol or change to this protocol version 1. Or 2, which is the solution they chose, being to simply include the extensions in their version 0 format in a string within the protobuf message. Now, this unfortunately reduces a lot of the benefits of switching to protobuf, as you are no longer saving bytes in the message, nor can you use the standard protobuf format to index the data, but rather you need to go back to integrating any methods which you may have created for version 0 back into version 1 to access all the extensions. So we believe that, furthermore, there's an inconsistency within the versions within version 1 between the federation data and data coming between ATAK and TAKServer. Just another example of how this inconsistency propagates. Moving on, our solution. So we've addressed how it proves detrimental in the long term to that being the propagation of undocumented extensions. However, it doesn't do anyone any good to complain. So we propose the implementation specification-driven development as a method of mitigating this complexity. Not only mitigating, but maintaining a specification. This specification-driven development is what's allowed us at the FTS team to have such rapid prototyping of FTS's implementations of the COT structure, but not only the COT structure. Furthermore, almost every feature of FTS has been developed using the specification-driven development, which has allowed us to get as far as we have with as few resources that we have. changes can be changes to the specification can be generated immediately in both the code base, the documentation, and the interfaces simultaneously, which is really fantastic if you think about the ramifications of this, which we'll get into later, but it's of huge benefit in the process of DevOps, which Gio had touched on in his presentation. All of this has allowed the FTS team to achieve the results which we have in a very small time frame with almost no resources. So I'm just going to delve a little bit further into what exactly is specification-driven development. Now, specification-driven development and model-driven architecture are not the same thing. However, for the purposes of this presentation, I will use the term interchangeably. These are the 5 steps which we've implemented in our process of developing FTS to achieve the results which we have. And I'll walk you through each of these images and what exactly they are. So we begin with the TAKServer use cases. What a use case is, for those of you who are not familiar, is an interaction between a client and a system. The system in this instance is FTS, obviously, and the client could be a ATAK, WinTAK, Radicat, or Sensor, though these are more future concepts. As you can see, the WinTAK and ATAK clients can interact with the server in a variety of different ways, be it dropping a ping, sending a geo chat, connecting, disconnecting, sending an emergency, sending a medevac. I could go on, but I won't. At this point, you can transform this into a behavior model. A behavior model will generally be a high-level explanation or visualization of the series of steps which need to be taken in order to achieve a certain or an expected result from the client side. However, these steps need to be taken by the system, which, as I said in this instance, is FTS. From this point, you take those components which you've established in the behavior model and you create a domain model. Now, a domain model does not contain any sort of logic. All it has is, firstly, the various classes which are being used. Secondly, within those classes, the methods and attributes associated with them. And furthermore, not the interactions, but rather the associations between these classes. For example, inheritance or utilization of one another. So in this instance, you can see this is a domain model of COT. We'll get a more comprehensive one later on in the presentation. This is an older diagram. However, you get the general idea. At this point, you can generate the code directly from the domain model into whatever language, because this domain model is described in UML, which stands for Unified Modeling Language. It is entirely platform independent. So for our instance, we generated Python code. However, it could be generated into Visual Basic, C++, Java, anything really. So here we've generated the class event and all its the code stubs. Furthermore, each of these up here, just going back to the previous diagram, contains associated documentation, not only with the class as a whole, but each attribute and method, making development a whole lot easier, because this doesn't generate the logic, but as I said, it generates the code stubs. The documentation helps a great deal when including this logic. At this point, you can generate the interfaces. associated with the domain model in any language. As I said before, this is described in UML. Therefore, it can be converted to nearly any scripting, programming, or protocol language. And we'll get into these, the behavioral models, the domain models, and the interface generation in a later slide. So moving on, I'm just going to get in a little bit more detail about what exactly a behavioral model is. A behavioral model, as I said previously, represents high-level transactions within a system to achieve a certain goal. In this instance, this this behavioral model is representing the transaction to negotiate protocol version 1 from protocol version 0. Just to get an idea, this is from information which we found within the description.txt or protocol.txt file. For those of you who haven't seen it before, it's a almost hidden file within the ATAK source code containing a description of protocol negotiation. However, it certainly doesn't come through this clear. It's very confusing, and actually, I had several headaches while reading through it. Corvo, the angel he is, went through it enough to extract this logic and describe it all within a model. Just to get an idea, each rectangle is representing a action being taken by either the client or the server, and each diamond is representing a yes/no decision. So there are a lot of steps, as you can see. This can then be generated into code like this, which includes all the documentation present within this model, as each of these has associated documentation which is included. Moving on, we have a structural model, also known as a domain model. This is a much more comprehensive model of COT, which we've created, or Juice taken the lead on this one. However, it's proved invaluable in the development of FTS. As you can see here, what's in green are the core components of any COT message, being events, point, and detail, followed by extensions, which are in red, and unsure. These, we believe, are present within the overall COT schema. However, we're not certain. We've seen references to them in the documentation, but never completely in COT form. Just to get an idea of how complex this is, there are currently 35 extensions in this model alone, each having, well, there are very few, there are two that have no attributes, but each having one or more attributes. Some, for example, images, here having upwards of 10. So this was a huge amount of work, and as we understand it, this is currently the most comprehensive model of or documentation of COT there is. Furthermore, each of these classes and attributes has associated documentation which is available within the model and can then be generated into any format you can think of, describing what each class and attribute contains and does. So it really is just an amazing feat on Corvo's behalf. So it's just a huge benefit to the community. Moving on, we are at This is the EA Schema Composer. For those of you who aren't familiar with EA, it is the central tool which we've used to drive this project. It has been an invaluable resource and has allowed us to conduct ourselves in the manner which we have with reference to specification-driven design. As you can see here, I'll just zoom in a little bit so you can have a better look. It is selecting the core components of any COT message, being point, event, and detail, and then two following extensions, being TAK control and TAK support. At this point, you can select which attributes from each class you would like to include, which forms a schema for a message, being TAK protocol support message. This is a reference to the earlier slide of the behavioral diagram that you saw, which was the protocol negotiation. This is one of the key messages within. This can then be used to generate identical interfaces in different languages, such as XSD, ProtoBuff, or JSON. But the really important part to remember is that all the interactions and specifications for these will be identical. There will be no differences other than the protocol in which they're implemented. And furthermore, they will use the same documentation, which can also be generated, which really is, I find it's amazing. So that pretty much concludes our presentation, or my presentation. I guess the key takeaways from this would be, firstly, that having a specification-driven approach greatly allows you to speed up development of applications, which in this context was FTS. Secondly, it ensures that technology can be perfectly aligned with the specification at hand, in addition to the documentation which has been created. I don't know if there are any developers listening, but personally, I am not a huge fan of writing documentation, and I've never met anyone who is. So I found that to be a huge plus. And lastly, FTS is a working example of this strategy and design philosophy, which we believe could be extended to all other members of the TAK family, or nearly all other members of the TAK family, in an efficient way that would greatly benefit all involved parties, both the open source community and government bodies. And that essentially concludes my presentation. I'd like to thank you all so much for listening. And I should have time to take questions now if there are any.
So thank you so much, Natha. And it's very, very late. So people is kind of falling asleep. So we still have 132 people online. But if you have any question in regard to what we have shown, and as you know, Natha is online and available. Maybe when you are more rest, if you want to, discuss with him how we are developing FTS, feel free to ask questions in Discord and also in the Reddit. So at the end of this conference, I would like to ramp up and to go through all the people that I have made that possible. First of all the speakers that have provided a very, very wide overview of information. So I'm going to share again, and we will go through the single speakers so that I can thank each of those. Okay, so I have the presenter. Where's my presentation? Here. Sorry, I've started to be a little bit tired here.